Good afternoon, my dear teacher friends.
Good afternoon, sir.
Good afternoon, sir.
Fine. I'm audible to all of you, I hope. Okay, fine. Today we shall discuss certain things related to this concept of global warming and climate change. Globally, there is a hue and cry that the climate change is taking place, and we should think of checking this, or we should practice certain things which is necessarily reducing, which is necessary for reducing the temperature, which is increasing day by day. That is what is the concern globally that we are seeing. Why there is a hue and cry about this global warming everywhere? Because nobody would like, generally nobody would like to have an increased temperature beyond their threshold or the limits of tolerance. So that is why everybody is concerned about this global warming. Now, what is this global warming? It is very simple. A gradual increase in the average temperature of the surface of the earth as well as in the lower strata, lower layers of the atmosphere, we call it as the global warming. So in other words, in simple words, increase in temperature of the earth's surface as well as on the lower atmospheric region is called the global warming. Why this temperature is increasing day by day? So we are all aware of the fact that mainly global warming is resulting because of the increased concentration of the greenhouse gases in the atmosphere. What are these greenhouse gases? These greenhouse gases are nothing but carbon dioxide, oxides of nitrogen, methane gas, and water vapors. Though water vapor is not a gas, it is considered to be one of the components in greenhouse gases, which is responsible for causing this global warming. Now, why this global warming is happening? And what happens when this global warming is taking place? We know that solar radiations are striking the Earth's surface. Solar radiation, sun rays are coming from the Earth's surface. And when they strike the Earth's surface, they will be reflected back. Now, whatever the amount that is striking the Earth's surface, if all the radiations are escaped, then there would have been no variation in the temperature. We know that solar radiations carry high energy, right, packets. So the light particles, the radiations which are traversing in the form of particles, which we call it as scientifically as photon molecules. So each light particle or each light particle of the radiation, it possesses certain amount of energy. So this amount of energy, which is also having the heat energy, whenever it strikes the Earth's surface, whenever the radiation strikes the Earth's surface, the energy of the radiations are being absorbed. The energy of the radiations is going to be absorbed. So not all the radiations are going to strike the Earth's surface, because if you say 100% of solar radiations are striking or entering towards the Earth's surface, more than about 50 to 52% is been filtered out. It will be reflected back from the atmosphere itself back to the space. Only about 48% of the solar radiations is known to strike the Earth's surface. That means it reaches to the Earth's surface. Now, these amount of solar radiations that are reaching the Earth's surface, when they strike the Earth's surface, they get reflected back. So when they get reflected back, once again, these reflected radiations escape out of the atmosphere. However, when some of the radiations are striking the Earth's surface, the heat energy is being absorbed. The surface of the Earth gets heated up. And when the radiations are after striking the Earth's surface, they want to escape out of the atmosphere. but they cannot escape out of the atmosphere because of these greenhouse gases. So these greenhouse gases act as a sort of umbrella. They act like an umbrella. So on the lower surface of an umbrella, you know that the reflected radiations will strike and get re-radiated back. So likewise, in the atmosphere, the solar radiations wants to escape, but because of these greenhouse gases which have been accumulating right in the atmosphere, these radiations strike them and get re-radiated back. They get re-radiated back. So this radiation and re-radiation is continuously taking place because of the increased concentration of these greenhouse gases. So as a result, the surface of the earth gets heated up, and that is what we call it as the global warming. In other words, you may ask me one question: why earlier was it not there? Yes. So over a period of time, this temperature is increasing on the surface of the earth. The reason is because we are also increasing the carbon dioxide concentration, methane gas concentration, water vapors, oxides of nitrogen. In other words, greenhouse gases are increasing in the atmosphere. And when they increase in the atmosphere, the barrier for the escape of radiations is also increasing, so that these radiations cannot escape out of the atmosphere. Once they strike these gaseous components of the greenhouse gases, they get re-reflected, re-radiated, we can say, not reflection, re-radiated back to the earth, so that once again they strike the earth's surface. The heat energy is being observed, so the surface is getting heated up. So that is how, in other words, we can say in simple terms, the heat loss from the earth to the space, the heat loss from the earth to the space is slowed down. That is what we call it as global warming. Why this global warming is happening? Global warming is happening, right? And because of this global warming, the climate change is also taking place. And the main reason for this global warming and climate change is the change in greenhouse gases concentration. So I am showing you that the greenhouse gases are carbon dioxide, methane, and even oxides of nitrogen, water vapor. So they are naturally being released right into the atmosphere. But in addition to that, the man-made activities is also responsible. For example, chlorofluorocarbons is also responsible for the increase of temperature. Ozone layer is also responsible. I will come to these things later when we discuss subsequently in the subsequent slides. So the first reason for global warming and climate change is the change in greenhouse gases concentration. The second reason is variation in solar radiations. Solar radiations. That means in some regions you will see the greater amount of solar radiations is striking. In some regions it may be less. It all depends upon the distribution of these greenhouse gases. Distribution of these greenhouse gases, number one. And also the presence of the ozone. The presence of the ozone molecules in the atmosphere. So, based on all these things, you will see the penetration of solar radiations also varies. So, variation in solar radiation is also responsible for causing global warming. And it has been estimated, or it has been deduced, that the Earth is undergoing a slight tilt, right? That is deviation in the Earth's orbit. Deviation in the Earth's orbit. So that is also responsible for global warming. So let us look at these things one by one in detail. Now we know that in the atmospheric gases include mainly there are so many gaseous components. Mainly atmosphere contains nitrogen, oxygen, argon, which are greater than 99%, and they are referred to as non-greenhouse gases. They are referred to as non-greenhouse gases, while this water, carbon dioxide, methane. So they are considered to be the greenhouse gaseous components which are less than 1%. Right? If you say there is 100% gaseous components in the atmosphere, these, the so-called or the supposed greenhouse gases constitute about less than 1%, while the non-greenhouse gases constitute more than 99%. Why do we say these gaseous components like carbon dioxide, methane, water as the greenhouse gases? Why do we call them as the greenhouse gases? What is a greenhouse? Normally, greenhouse is a room or a building that has been constructed in a botanical garden. It is a glass house. It is a room or a building that has been constructed in a botanical garden, wherein the side walls of the room, or at least the roof of the room or the building, is made of glass. Is made up of glass. It is typically like a glass house. It is typically like a glass house. And in this room, there will be a door wherein you can lock it and you can unlock it. So it will be having a door, which wherein it is going to be completely locked. Now, why this greenhouse is going to be established in a botanical garden? So it is in order to keep certain plants which are endangered or which are rare, which are of very much importance in conservation. So those plants are going to be kept in a greenhouse, in a glass house, and they will be maintained. They will be maintained. They will be protected. They will be conserved. Now, when these plants have to be conserved in a greenhouse, they must receive the sunlight, because you know that plants essentially prepare the food material. They undergo photosynthesis. So from the glass roof, or the glass window panes, the light enters into the greenhouse, falls onto the surface of the plants that have been kept inside the greenhouse. Right. So these plants can utilize these solar radiations and start growing after the manufacture of the food material. And also inside this room or the greenhouse, there will be what? Gases like carbon dioxide. There will be also water vapor, and also people who maintain these plants in the glass house or the greenhouse will water the plants. Water is essential for the growth of the plants. You will water. The excess of water that is absorbed by the plants will be once again released outside in the form of water vapors, which we biologically call it as transpiration, So through the process of transpiration and also through the process of evaporation. So the water vapors are released into the indoor environment of this greenhouse, or released into the indoor environment of the greenhouse. Now, when such type of water vapors are being released, carbon dioxide is also released during photosynthesis, right? And you add normally fertilizers for these plants to grow. So the fertilizers that have been added to the plants will also capable of releasing this methane gas and also nitrous oxides. So oxides of nitrogen, water vapor, carbon dioxide, and methane. All these things are released in a greenhouse or a glass house. When they are released into a greenhouse or a glass house, right, we know that these gases cannot escape out of the greenhouse, because you have constructed this room or building in such a way that there is no entry of other gaseous components from outside. So only inside you will be having an indoor environment, and if you open the door, there will be the gaseous components, and the solar radiations are entering through the glass panes or the glass roof. So they strike the plant surface. Plants utilize the available oxygen inside the glass room. They use available water fertilizers, likewise they will grow and develop. Now these gases, when they are there, they want to escape. Once they are released in the indoor environment, they want to escape outside, but they cannot escape outside because the glass acts as a roof for them. And the gaseous components that are present acts as a barrier to allow these radiations, to allow other striking or entered radiations to escape out of the indoor. So these radiations reflect back, strike the roof and get re-radiated back. They strike from the plants or the parts that have been kept inside a glass house. They want to escape out of the glass roof. They cannot escape. So after striking this glass roof, once again they are reflected back. So likewise, continuous radiation and re-radiations take place even inside a greenhouse. So that is why when you open a greenhouse and enter, you feel very much warmer. You feel very much warmer. That is, the heat energy is being absorbed inside the indoor environment from the soil surface in a greenhouse or a glass house. So the same process also takes place very naturally outside the greenhouse. So that is why it is called greenhouse gases. So same gases, whatever that they are released inside a glass house or greenhouses, is also being released, is existing outside the greenhouse gas or outside natural environment. That is why these gases are considered as the greenhouse gases. This comparison of the phenomenon that is taking place as global warming inside a greenhouse because of greenhouse gases, and outside the greenhouse also because of this building up of the greenhouse gases, is compared by the scientist Alfred Laplace. A-L-F-R-E-D, Alfred Laplace, L-A-P-L-A-C. Alfred Laplace was the scientist who compared this natural phenomenon that occurs in a greenhouse to that of the one which is taking place in nature. So that is how these gaseous components which are involved in causing an increase in temperature are referred to as the greenhouse gases. Now, what are the chief sources of these greenhouse gases? The greenhouses are mainly generated by the human activities, by the human anthropogenic activities. We burn fossil fuels. When fossil fuels are burnt, carbon monoxide or oxides of nitrogen or likewise they are all being released into the atmosphere. Carbon monoxide combines with oxygen and forms carbon dioxide. So various oxides of nitrogen being released. So even burning of petrol, diesel, all these things releases such type of the greenhouse gases. And the second factor is the second source is about deforestation. When you cut the trees, what happens? The carbon dioxide concentration increases in the atmosphere. Why? Because we know that plants are the one which are capable of absorbing the carbon dioxide. Using this carbon dioxide, they manufacture the food energy in presence of sunlight, in presence of water, in presence of chlorophyll. So using these raw materials of water, chlorophyll, solar radiations, and carbon dioxide, the plants are going to prepare the food or manufacture the food, which we call it as photosynthesis. So if plants are cut, if trees are removed, so the photosynthetic area gets decreased. So the photosynthesis is decreased. So when photosynthesis is decreased means the plants are no more there to absorb sufficient amount of carbon dioxide present in the atmosphere, so that the carbon dioxide concentration increases in the atmosphere. So thus deforestation leads to the release, or we can say the occurrence of the greater concentration of carbon dioxide in the atmosphere. Every year, more than 2 billion tons of carbon dioxide is loaded into the atmosphere. 2 billion tons of carbon dioxide. If greater forest cover is there, the forests are the one which are capable of absorbing this carbon dioxide. So an ideal forest cover as prescribed by National Forest Policy is about 33%. 33% in any geographical area. So the 33% of forest cover should be there, but we are not having the same quantum. Now, thus, deforestation activity leads to the release of the greenhouse gases or for responsible for the increased concentration of the greenhouse gases. Extensive rearing of livestock is another source, right? How it becomes? Because we know that India is ranking number 1 in the cattle population. India is ranking number 1 in the cattle population. We are almost having 16.1% of the cattle population of the world. We are having. So followed by the Brazil and China and Brazil. So now, through this dung of this cattle, what happens? Methane gas is being generated. Methane gas is also being generated by the fertilizers. So that is another reason or another source of these greenhouse gases. Extensive use of cooling agents, blowing agents, insulating, packaging materials, aerosol sprays, solvents. So from all such activities, man-made activities, anthropogenic activities or industries, we can see the release of the methane gas or oxides of nitrogen or any even carbon dioxide. Likewise, so from extensive using of these things also, we are seeing that the greenhouse gas concentration is increasing in the atmosphere. So these are the sources of the greenhouse gases. Now let's see one by one what type of greenhouse gas and how it is going to be released. So carbon dioxide. So carbon dioxide is the one which is going to absorb the heat energy when the solar radiations strike the Earth's surface. When it is reflected back, carbon dioxide is going to trap the heat energy. It is produced always by burning of fossil fuels. Even carbon dioxide is also produced by burning of fossil fuels like gas, diesel, petrol, etc. Right? And the amount of carbon dioxide concentration is rising 1% every year. In the last 150 years, about 30% of carbon dioxide is increased. So just imagine now, every year, day by day, we are seeing the uploading of the carbon dioxide concentration. See, to show you, this much is the total land area of the Earth. I am showing you, displaying it on the screen. So the population of the world as on 16th February, I could take. So is that much. That means we are having, why these statistical figures are important, you will come to know about it probably at the end in a better manner. Now, world forest cover as on today is about 30.71% as against an ideal forest cover of 33%. And in India, we are having about 23.68% of the forest cover. Total land area of the country is 328.7 million hectares. In other words, we are just having 2.47% of the world geographical area. And with this much of area, now with these statistical figures show very clearly that our population is increasing, our cattle population is increasing, our geographical area is not increasing, it is limited. It is limited. Our demand for the natural resources like firewood, timber, medicine, right? All these are fruit, fodder, they are all increasing, isn't it? So we are putting lot of pressure on our natural resources. We are putting lot of pressure on our natural resources. So when we are in demand of plenty of such type of natural resources, like say for example timber resources, we cut the trees. So when we cut the trees, the carbon dioxide concentration increases because if there are no trees, So there are no trees to utilize this carbon dioxide to prepare the food energy. See, look at as on January 2020, the carbon dioxide concentration in the atmosphere was 413.61%. And in 2021, it is 415.52. So day by day, we are experiencing an increased concentration of the carbon dioxide. So in the beginning of 1900s, the atmospheric carbon dioxide concentration was 282 ppm in the beginning of 1900s. So the atmospheric concentration of carbon dioxide is around 282. Now we are having 415.52. You look at almost we are having double the amount of carbon dioxide concentration in our atmosphere. So this is mainly responsible for causing this global warming. So of all the gaseous components, especially the greenhouse gases components, if you say, the major culprit responsible for causing this global warming is carbon dioxide. So its concentration is increasing. Now all this data, even up to date, every month, every day they record this concentration of these greenhouse gases, and it is being carried out by a team of scientists at National Oceanographic Atmospheric Administration, NOAA. They have got special instruments, devices, manpower, everything. So they are going to measure and update it, right? That's how we could make out what is the present carbon dioxide concentration. And once a carbon dioxide is being released into the atmosphere, each molecule of carbon dioxide remains active in the atmosphere for about 200 years. So in other words, the atmospheric lifetime of carbon dioxide is around 200 years. So thus we could see carbon dioxide concentration is increasing. The second most potent greenhouse gas is the methane gas. So methane is being generally produced by the natural sources and also by the decomposition through the methanogenic bacteria. Even through the methanogenic activity of the methanogenic bacteria, so we are seeing, especially in the paddy fields when you add fertilizers, dung, etc. Through their activity, we are seeing the release of the methane gas. Methane is another greenhouse gas which is effectively absorbing these outgoing infrared radiations. There are also type of solar radiations, UV rays, infrared radiations. All these are all the various radiations based on the wavelength of the radiations. It has been classified. So most of these methane is going to be released, which is going to be released by the cattle, is going to absorb these solar radiations very effectively, and once again reflect back to the Earth's surface. So that is how they are also mainly responsible for causing this global warming. According to some estimate, about 100 million tons of methane is released annually. 100 million tons of methane is released annually. Now the third greenhouse gas or component is nitrous oxide. So it is a colorless, non-flammable gas with a sweetish odor, commonly known as laughing gas. And this is naturally produced by oceans, rainforests, soil. And the sources of nitrous oxide include the usage of fertilizers in agriculture, catalytic converters, and also by burning of organic matter. So these are all through various such activities we are seeing the release of this nitrous oxide. So that means very naturally through the phenomenon of the microbial action, we are seeing nitrous oxide is being released into the atmosphere. Even through anthropogenic activities, we are like in burning of fuel in the automobiles. So we are seeing what? The release of nitrous oxide. So thus we are seeing the carbon dioxide concentration, methane gas concentration, they are all increasing in the atmosphere. Water vapors, whatever the excess of water that is being absorbed by the plants and as well as through various aquatic bodies, oceans, lakes, rivers, pools, ponds, water get evaporated. So likewise, when the water evaporates, they get accumulated in the atmosphere. So in other words, if there is a greater amount of the water vapor, never be under the impression that so we will be having a cooler condition. So greater the water vapors being accumulated in the atmosphere, greater will be the absorption of the reflected radiations, so that it will absorb and re-reflect it, re-radiate it. So that is how even water vapors are going to be responsible for causing this global warming. You see in the coastal area, in the coastal areas, even in winter season, even in the rainy season, you feel very much hot. The reason is because this phenomenon. So an increased concentration of water vapor, right, in the atmosphere is responsible for causing this global warming. Now, I told you, what is this greenhouse? Sorry, what is this greenhouse effect? Right. So, in other words, increase in temperature of the Earth's surface as well as the lower atmosphere because of the increased concentration of the carbon dioxide, methane, oxides of nitrogen, and water vapor. So, just a photo. See, look at when all of them are striking, some amount of energy is absorbed and some radiations are reflected back. When these are reflected back, if they strike in the atmosphere, the atmospheric layer, once again they will be re-reflected back, re-radiated back, because this is being carried out by the increased concentration of carbon dioxide as well as methane, which act as the greenhouse gas. Now, what would be the temperature? Planets with very little greenhouse effect are either very cold. Now, of course, Pluto is discarded. The planet. But when it was supposed to be there, that it was existing, and they could establish the fact that the temperature of the Pluto is about minus 370 degree Fahrenheit. It's very, very, very cold because there were to be no greenhouse gases. Or there may be a huge temperature swing from day to night, as much as the difference of 300 degree we can see. So this can be seen in the Mars planet. So that means in Mars there is a varied concentration of these greenhouse gases, which is responsible for resulting in this global warming. And planets with abundant greenhouse gases are very, very hot. For example, in Venus, we have got plenty of this concentration of these greenhouse gases. So, carbon dioxide or methane or water vapor or like that. So, through natural phenomenon also, right, we can see such type of gaseous components are being released. That is why the average temperature on Venus is about 855 degree Fahrenheit. Of course, then there is Earth at the moment, we can see. Now, had these greenhouses were not to be there, assume for a while, had this greenhouse were not to be there in the Earth or in any planet, what would have happened? Is this greenhouse gases are necessary? Yes, it is necessary. You do not want absolutely the elimination of these greenhouse gases. You need to certain extent, right, the availability of or the existence of these greenhouse gases in our atmosphere. So, if there were to be no greenhouse gases on the Earth's surface, the temperature of the Earth would have been 0 degree centigrade, isn't it? Or, I'm sorry, minus 18 degree centigrade, minus 18 degrees centigrade, or it would have been right 0 degree Fahrenheit. So when no greenhouse gases are there in the atmosphere at all, scientists estimate that the Earth's average temperature would have been minus 18 degrees Celsius or about 0 degree Fahrenheit. So we need greenhouse gases in an optimal level for to have an optimum temperature, but we do not need the concentration of greenhouse gases to be increased to cause an increase in the temperature of the earth, right? So that is how greenhouse gases are the one which regulate the temperature on the surface of the earth. See, look at how much these greenhouse gases are being contributing to the global warming. In the beginning, as I told you, that carbon dioxide is the major culprit responsible for causing this greenhouse gas, global warming and subsequently the climate change. It contributes about 64% to global warming. If you say there is 100% global warming, carbon dioxide contributes about 64%. Methane contributes about 19%. Methane contributes about 19%. And oxides of nitrogen. So we know that not only even from the fertilizers, even from industries, we can see the release of these oxides of nitrogen. It contributes about 6% to this global warming. And chlorofluorocarbons, though it is not being naturally produced, it is being produced through anthropogenic activities, wherein you are using the refrigerators, air coolers, air conditioners, so through which you are releasing the chlorofluorocarbons. So they contribute about 11% to the occurrence of, or for the occurrence of, or for resulting this global warming. So global warming is taking place mainly because of the concentration of these things, and the different role played by different factors include this concentration of these greenhouse gases. Now, if the amount of solar radiation or the energy, now we know that the solar radiations are striking the Earth's surface. Now, whatever the solar radiations that are striking the Earth's surface, and once they strike the Earth's surface, they get reflected back. So, whatever the amount that is absorbed and whatever the amount that is reflected back, if both of them are equal, then the temperature would remain constant, because once it reflects, it gets reflected back. Once it strikes, reflects. So the concentration, the temperature remains constant. But whenever the radiation strikes the Earth's surface, and if it is before reflecting or even after reflection, once again it is striking the greenhouse gases and getting re-radiated. For every strike, some amount of heat energy is being absorbed. For every strike of the radiations, some amount of the energy is being absorbed. So when the energy is being absorbed, automatically the Earth itself gets charged, so to say, gets heated up. So that is how the global warming takes place. So if the amount of solar energy absorbed is greater than the amount that is radiated back, then the Earth heats up. So certain amount of radiations are striking the Earth's surface. When they strike the Earth's surface, so not all the radiations can escape, only a few radiations will escape, but greater radiations are going to be what? Absorbed by the Earth's surface. Then the Earth's surface gets heated up. The reason is because, see, the radiation strike the Earth's surface. They reflect back. When they reflect back, they should escape out of the atmosphere. They cannot escape out of the atmosphere because of these greenhouse gases. So when they strike these, they get once again the same radiations re-radiated back to the Earth's surface. So once again, the amount of heat energy is being absorbed. So that is how the continuous radiation and re-radiation, and when the amount of solar energy absorbed is greater than the amount that is radiated back, then the earth gets heated up. That is what we call it as the global warming. Suppose whatever the amount of solar radiation that is going to be absorbed, some amount of radiation is being absorbed, and it is less than the amount that is radiated back. Say, if there is 100 radiations, right? There is 100 radiations, and about say 80% radiations are reflected back, only less amount of radiations are striking, then automatically the temperature is cooled down, isn't it? It decreases. So the earth gets cooled down. So that is how, based on the concentration of these greenhouse gases, we can see the increase or decrease in the temperature. Now, another parameter that I told you responsible for this global warming is the orbital parameter, obliquity. It has been suggested that the earth is undergoing a tilt. It is undergoing an obliquity. The earth tilt goes from a minimum of 22.5 degree to a maximum of 24.5 degree, and at present the earth has undergone a tilt to an extent of about 23.5 degree. So an earth can undergo a tilt from a minimum of 22.5 to 24.5. The present tilt is 23.5. So only this much tilt it can undergo. That is what the scientists have projected and predicted. Now when the such tilt is going on, what will happen? See, look at, when a tilt takes place, the amount of incidence of the solar radiations also varies. The incidence of amount of solar radiation also changes. So thus the solar radiation concentration, when it is altered, so their striking is altered, the temperature of the earth is also getting altered. So that is another factor responsible for global warming. Now, what do you mean by ultimately say that what is global warming? Means we experience an increase in temperature. If the temperature is increased, the climate also changes, isn't it? When the temperature is increased, do you expect that the temperature, whatever the temperature that is seen in the winter season, to be the same in the summer season, in the rainy season? So it keeps on varying. So when temperature changes, the amount of precipitation or rainfall also changes. Ultimately, it results in a climate change. So thus, look at, even in this photo I am showing you, the radiations strike Earth's surface, they want to reflect back, they cannot escape because of the carbon dioxide. So through various activities, we are increasing this carbon dioxide concentration. So they get accumulated. So they strike these things, they can't escape. Once again, they will be reflected back to the Earth's surface. So likewise, the temperature of the Earth gets heated up. And how much of temperature is increasing on the Earth's surface? So there are various scientists who carried out the work in various places, and in different biogeographical area, different increase in temperature, has been recorded. Some studies have proposed that up to 9 degrees Celsius of an increase has been projected in some areas, and in some areas they have projected that a minimum of 1.5 degree centigrade or Celsius and a maximum of 4.5 to 6.2 degrees Celsius of temperature change takes place or is happening. So various studies have been have resulted in proposing various, what we can say, degrees of temperature alteration. But however, the studies have shown very clearly that the temperature is increasing every year. And now recently, if you can look at about a week's back data and the information through various research papers, you can understand that 2018 and 2020 are considered to be the hottest years in the last decade. in the last decade, 2018 and 2020 are considered to be the hottest years. Now, we know that the temperature of the surface is increasing, resulting in global warming. And in the beginning, I also told you that in addition to this natural way or natural phenomenon that is taking place, anthropogenic activities is also sometimes responsible for enhancing, increasing this global warming. And one such reason is the ozone depletion. We know that ozone layer, right, if at all is present in the stratosphere, that is the atmospheric layer of the earth has been divided into various layers, various strata, right? So a distance from the ground surface of the earth to up to a distance of 40 kilometers, you call it as troposphere. Then above that, you will see above 40 kilometers, stratosphere. And about 50 kilometers onwards, you will see mesosphere. And after about, say, above 50, 60 onwards, you will see 300 kilometers up to thermosphere. And beyond 400 kilometers, you will say exosphere. So whatever the solar radiations that are striking this Earth surface has to reflect back, and ultimately it has to escape. It has to escape. But in the troposphere itself, you are having this increased concentration of carbon dioxide, methane, water vapor, everything. So they want to escape, they cannot escape. They strike it here and get reflected back, get re-radiated back. So because of such radiations, reflections, re-radiations, the surface of the temperature of the Earth is getting heated up. Now, ozone layer is generally present in stratosphere. So, whenever ozone layer is present in the stratosphere, it is an eco-friendly layer. It protects the harmful UV radiations being penetrating through the atmosphere and striking the Earth's surface. Now, why this ozone layer is getting thinner and thinner? So, you might have heard the word ozone hole, ozone hole. Hole, an exact hole-like structure you do not see in the atmosphere. No gases will be having an exact hole-like structure. Wherever these molecules are being deposited, and wherever there will be a thinning, and that means the concentration of these gaseous molecules are very less, and such area becomes very much thinner in the sense the concentration of these gaseous molecules will be very less. So such thinner areas of the ozone with respect to ozone layer, we call it as the ozone hole. And whenever the thinning areas, which you call it as very popularly as ozone holes, so in that region, the UV radiations from the sun directly enters and strike the Earth's surface. When it directly enters and strikes the Earth's surface, remember UV radiations also carry high energy molecules. So when these high energy molecules are striking the Earth's surface, so greater amount of, once again, the heat energy is being absorbed. So that is how the depletion of the ozone layer is also responsible for causing the global warming. Of course, this concentration of this ozone is measured in certain units scientifically, which we call it as Dobson unit. Dobson units. Now, if I just say here, the thermal stratosphere, I am not going into the technicalities and detailed definitions and explanation of the scientific terms here. All right. Just I am trying to convey you how exactly these are going to be expressed in ppm, parts per million, Dobson units, various gaseous components. Now, this is how in the stratosphere, if ozone layer is present, it is very good for all the living entities present on the Earth. And if this ozone layer descends down to the what? Troposphere, nearer to the Earth's surface, it is a dangerous layer. Why it is a dangerous layer is because it is going to form photochemical smog. It is going to form photochemical smog under the influence of light. Probably in the previous lecture, I have told about this Los Angeles smog and London smog, Los Angeles smog, or photochemical smog. So a chemical reaction takes place between the hydrocarbons, oxides of nitrogen, ozone, isn't it, to form peroxyacetyl nitrite bond. So all these things I told in the previous lecture. So that is how ozone in the troposphere is a dangerous layer, but ozone in the stratosphere is a beneficial layer. So if such ozone layer is going to be depleted, then you will see the global warming is enhanced. So we know that ozone is formed. How it is formed in the atmosphere? When two oxygen atom reacts with one oxygen atom, it forms, right, a group of 3 oxygen atoms, which we call it as ozone. So a ozone molecule is having 3 atoms of oxygen, that is 3 atomic oxygen. If it is having 2 oxygen atoms, it is oxygen. So oxygen is necessary for us. Oxygen is required for us, for our breathing, for all living entities. We do not require ozone for breathing. We do not require ozone for breathing. So the reaction between the diatomic oxygen and oxygen to form ozone is naturally taking place. And also sometimes the dissociation of ozone, splitting of this ozone into oxygen atom and diatomic oxygen is also taking place. So very naturally this is happening. But this layer, this ozone layer should not be damaged. So nature has taken care of the natural balancing of this concentration of the ozone layer in the atmosphere, or for that matter in general any layer, any gaseous component. If this ozone layer is there at ground level, as I told you, it is going to form photochemical smog, and when UV radiations enter wherever there is the depletion of the ozone layer, you can see skin cancer will be resulted. So why the depletion of ozone layer is taking place? Because when you use air coolers, air conditioners, refrigerators, all these things, so it releases CFCs, chlorofluorocarbons. It releases chlorofluorocarbons. Each CFC molecule, each single CFC molecule containing chlorine atom can bring about the breakdown of one molecule of ozone. Each single CFC molecule is capable of bringing down the breakdown of 1 lakh molecule of ozone. You just imagine if that much of ozone molecules are damaged, what happens? It results in what? The penetration of the UV radiations. So that is how ozone at stratosphere is an eco-friendly layer, but at tropospheric region, it is a dangerous layer. Now, what are the causes for depletion of this ozone? One major such cause is the release of CFCs. Even presence of certain oxides of nitrogen, halogens, these are all certain chemicals, because halogens is a group of chemicals containing various compounds like chlorine, bromine, iodine, like that. So all these are responsible for causing the depletion of the ozone layer. And when this chlorine atom of the CFCs react with the ozone layer, this is a chemically, how the chemical reaction takes place. So it forms, look at this, ClO plus O2. That means one oxygen atom of the ozone has combined with the chlorine, and another oxygen molecule, O2, 2 atoms of this oxygen has been released into the atmosphere. So that means if these compounds are formed, O3 will not be there. So that is how the ozone layer, look at this, harmful UV radiations are entering, isn't it? And CFCs are being released, which are damaging this ozone layer. So it is a simple diagrammatic way of understanding. And who worked out this? CFCs is going to damage the ozone layer. It is this scientist, Mario Molina, right, is the scientist who established worldwide for the first time that CFCs released from various anthropogenic activities are responsible for the depletion of ozone layer. For such a contribution, he was given Nobel Prize in chemistry in the year 1995. So, such an useful discovery that he has made, that you should not damage the ozone layer. Otherwise, the chances of UV radiations striking the Earth surface, living entities, plants, animals, microbes, human beings, results in various types of what we can say anomalies. Sorry, abnormal birth, abnormal growth, health hazards, all these things are going to be resulted when once the UV radiations strike the Earth surface. So, if we want to protect ourselves from the UV radiations, there should be the ozone layer. So, with all these facts known to the entire world population or scientific community, still we are using the refrigerator, air coolers, because we are doing deforestation, isn't it? Deforestation activity is going on, right, without any stoppage. So that is what is responsible for this global warming. See, CFCs are being released from various such sources, even electronic industries and even halons, fire extinguishers, right? They do release these things which can deplete the ozone layer. And some companies are using HFCs as a replacement for CFCs. So HFCs are slowly damaging the ozone layer, not as fast as CFCs. That means damaging is definite. Damaging is definite. So instead of dying today, you may die after 2 days like. So you are just simply slowing it. That's all. Now, that is how the ozone depletion. This is all the picture wise how the ozone depletion is taking place. So, ultimate, the net result is that the CFCs is also responsible for global warming and climate change. Health consequences also will be there. So, that means when ozone is depleted, there will be the chances of seeing the skin cancer like this, a health hazard. And even whenever the ozone layer is going to be depleted, what would be the impact? So the scientists have predicted within next 30 years, if UV radiations are striking the surface, 3% of the world's total production of legumes and other crops is going to be destroyed. 3% of what we can say, the productivity decreases. Why the productivity decreases? Because of the penetration and striking of the UV radiations. What are these legumes? All your green gram, red gram, horse gram, Bengal gram. So all pulses, whatever that you say, they belongs to legumes, right? Then coffee, I mean this jowar, ragi, rice, crop plants. So the productivity of this worldwide decreases by 3% if there are UV radiations. Now itself, people are struggling to get a square meals, isn't it? So, and you just imagine if 3% worldwide, if the productivity decreases, what would be the demand for the crop plants and the legumes? Today, if 1 kg of rice is costing as an average 50 to 60 rupees, if 3% of world's productivity is decreased, it may cost about 150 rupees. To that extent it may reach also, isn't it? All the people cannot be able to afford to purchase the crops, so people may be starving, and ultimately they may die. So all these possible, this is a projection, a scientific projection that has been made for the next 40 years with the present rate of damage to the ozone layer, right? So it has been well established by Environmental Protection Fund, comprising of the information, research investigations obtained from various scientists. Now, in knowing all these things, do you feel of using the refrigerator, air cooler, air conditioner? And you say that we want to keep all these things for our next generation, right? For next generation, a better what? A high capacity refrigerator, a better cooler, a better air conditioner, instead of growing the forest, isn't it? instead of maintaining the vegetation, instead of what? Reducing the deforestation activity. See, look at this is what is the result. Now, acid rain is another one which is responsible for this global warming. It's an impact of global warming and climate change. We know that whenever these oxides of nitrogen, sulfur dioxide, etc., are being released into the atmosphere, in the atmosphere, sulfur dioxide, for example, or oxides of nitrogen, they combine with water vapor and reaches to the Earth's surface as acid rain. It reaches to the Earth's surface as acid rain. How this acid rain is responsible for global warming? You may ask me. Whenever there are acid rain, when it is downpouring on to the surface of the earth, the soil becomes acidic. The soil becomes acidic. When the soil becomes acidic, can you expect the plants to grow? You cannot expect the plants to grow. The vegetation will die. So that means the trees get denuded of foliage, isn't it? Foliage have been lost. It is as good as like asking. If there is an acid, instead of having a bath through a warm water, have a bath through an acidic water. What will happen? Can you have an acidic water bath? All your skins and everything will be burnt. Likewise, you just imagine when such acidic rainwater enters the or strikes the earth's surface, how do you expect the plants and vegetation to be there? So wherever it may not necessarily be that it may not happen in all the places. If it happens at one place, the effect will be felt at another place. So ultimately, it is the cumulative impact of these things that an individual can experience. So when there is no vegetation, so once again there will be an increase in temperature. Acid rain, it may damage the buildings, it may damage the statues, and it may also result in respiratory diseases. So if you inhale the rainwater having these acidic vapors, it will affect your health also, respiratory problems. It may acidify lakes. If lakes are, that means whenever there is acid rain, so when the acid rain enters into a fresh in any aquatic water body like lakes, so the water becomes acidic. So if it becomes acidic, the aquatic organisms like fishes may not be able to survive. We know that, we know that fish is the major kind of food among the Swedish people. Swedish people, fish is the major food. But it has been 2 minutes. It has been scientifically established that more than 150,000 fishes die in the lakes of Sweden. And Swedish people are not having any such type of industries which can affect or which can result in acid rain. But surrounding this Sweden country, there are countries which are releasing this sulfur dioxide into the atmosphere. Once they are released, these particulate matters are diffusing. They are diffusing and reaching the Sweden country. By the time they are reaching into the atmospheric region of the Sweden country, it is a rainy season. So the water droplets react with this sulfur dioxide and downpours. That precipitation takes place in the Sweden as acid rain. And Swedish people will grow most of the crop plants there. There is no chance for them because almost all the areas are going to be affected with this acid rain. There is no fertility of the soil. The soil becomes highly acidic. So that is why they are dependent upon the other countries for their the food crops, especially the plant resources, plant food resources. And animals, they are dependent on fish. That is a major food for them. Even every year they are losing the fish population because of this acid rain. So thus, now here, an increase in temperature, depletion of the ozone layer, anthropogenic activities, climate change, like even acid rain. So all they are having a cumulative effect or an impact on the human life ultimately. See, look at when buildings get themselves corroded or damaged, sculptures, look at here, acid rain effect. a clear phase was there earlier after acid rain. So Mathura refineries you have seen, you might have heard, Mathura refineries near Delhi, which released this sulfur dioxide, which has been diffused and caused corrosion of the Taj building, right? Corrosion of the Taj building. So for no fault of the people of the Agra, the Mathura refineries or Mathura region, whatever the what we can say, the pollutant that has been released has resulted in causing the acid rain in the Agra region. Likewise, wherever you do carry out such activities, it is ultimately going to be having a strong impact on the life, whether it is a plant or an animal or the human beings. Now, that is what it kills, even microorganisms. It may kill, even it may poison the plants, and it may damage metals and limestones. It kills the fishes, right? Even if you hold an umbrella like this, it may damage your what umbrella if the acid rain is there. Okay. Now, and it affects your respiration. If you inhale the vapors of this acid rain, outside it is raining, nothing will happen. I am resistant or immune to this rain or precipitation. No cold and cough will take place like that. If you dare enough to go in an acid rain without awareness, then you inhale the vapors of this acid rain and it may damage and you may get respiratory problems. If it continues, it may die also. So throat irritation will be there if you swallow the vapors of their skin, right? Irritations will be there. So all these are the impacts that we can experience due to these things. Now comes when global warming takes place, the climate change also takes place, I said. Then what is climate? What is climate? Climate is nothing but the aggregated pattern of the weather, meaning averages, extremes, timing, spatial distribution, so many things. I think I have to give you a break, a tea break for 10 minutes. Okay. So let me take off here and I will be back here after 10 minutes to continue with this. Okay. Thank you.
Thank you, sir.
ಈ ಸ್ಲೈಡ್ ಇಂದ ಕಂಟಿನ್ಯೂ ಮಾಡಬೇಕು.